2024 A-Level Combined Mathematics Paper 2 Part A question number 2. This question has to do with projectile motion. The question says, a particle is projected from a point O on a horizontal ground with an initial speed of u at an angle theta which is in between 0 and pi by 2 radians to the horizontal. The particle hits a vertical wall which is at a horizontal distance of L from the point O and is also at a height h which is greater than 0 from the ground as shown in the figure. Now looking at the figure, we can see our particle is projected upward, it goes up and hits the wall at this point right here, and we can see the horizontal displacement here is L in this direction and the vertical displacement is h in the upward direction such that our final point is above the horizontal ground that we started from. Now given this information, we are asked to show that h is equal to L times tangent of theta minus g times L squared divided by 2u squared times secant squared of theta, and are asked to then deduce that we must have sine 2 theta being greater than gl divided by u squared. Now to start off with this question, what we need to do is to apply s equals ut plus half at squared to this system in both the horizontal and vertical directions. Now for this, let's assume that our travel time, or we could say flight time, is t. Now using this, if we apply s equals ut plus half at squared, if we say applying s equals ut plus half at squared, we can apply this in both the horizontal and vertical directions to get two equations that we can then use in order to find h and later find this inequality right here. So to start off, let's apply s equals ut plus half at squared in the horizontal direction. Now considering the horizontal direction, if I take the horizontal direction's rightward direction as being positive, I can see from our starting point to our ending point, we have a displacement of positive L like this. So therefore, our s is positive L. Now considering the rest of the terms here, our u is going to be a horizontal velocity, which in this case, our horizontal initial velocity is going to be u cosine of theta, and therefore in this direction we have u cos theta for our initial velocity u. Therefore substituting, we get u cosine theta times the time, which is just t since we defined it to be t. So therefore we get L equal u cos theta times t. And then for the plus half at squared in the horizontal direction, since we don't consider air resistance here, our actual acceleration is exactly equal to 0. So due to that, the half at squared term is equal to 0, so we can ignore it. Since a is equal to 0, everything that's multiplied by a is also going to be equal to 0. So therefore, from this we get L equal u times cosine of theta times t. We're going to call this equation number 1. Now similarly, if we apply s equals ut plus half at squared in the vertical direction, we can derive another equation. Now if we consider vertical upward as being positive, we can see from our starting point to our ending point in the vertical direction, we have a displacement of positive h. We went up by h. So therefore, s equals h. So we have h equals, and for the rest of it, we have ut plus half at squared here, and we can see u in the vertical direction is this bit right here, which is u sine theta since it's opposite angle, and therefore we have u sine theta times t and then plus half at squared. Now in this case, our acceleration is downward since we have the downward acceleration of gravity g. Due to this, if we consider the upward direction as being positive, then we have to take this acceleration g as being negative. So therefore, considering this downward acceleration of g, I can write that we have plus half times negative g times t squared as a second term. And I'm writing it with this negative g here because of course our acceleration g is in the downward direction, which is of course negative since the upward direction is positive. We're going to call this equation number 2. Now with this, what we want is an equation for h that does not contain t. As you can see here, this equation for h does not contain t. So for this, what we can do is to take equation number 1 and rearrange it to get t and then substitute every instance of t in our second equation. So for this, we can see taking equation 1, we can rearrange to get t equals, and if we take everything else to the other side, we get L divided by u times cosine of theta. Now what we can do is to take this equation, which I'll call equation number 3, and substitute it into 2. So I can do 2, 3. Now substituting 2, 3, I can see I get h equals, and then I have u sine theta times t, which is L divided by U cosine theta, and then we have plus this bit here, which is actually minus, since we have minus g, so I'll write that as minus 1/2 g times t squared, which is this term squared. So we have L squared divided by U squared cosine squared theta. Now if you simplify this down here, we can see we have h equals, and on the other side we have u, and we have divided by u here, which we can cancel out, leaving us with L times sine theta divided by cosine theta, and sine theta divided by cosine theta is tangent of theta. Therefore the first term here is h equals L times tangent of theta, and then we have minus this whole thing, which is minus half times g times L squared divided by U squared. I'm going to take this g and L squared to the top and this 2 and U squared at the bottom and write this as minus g L squared divided by 2 U squared. But then I have 1 divided by cosine squared theta and 1 over cosine theta secant theta, and therefore 1 over cosine squared theta is secant squared theta. So according to this, we get the equation we were looking for. It is h equals L tan theta minus gl squared divided by 2u squared times secant squared of theta. With that, we have solved the first part of the question and can now move on to the second part. So in the second part, we are asked to deduce that sine of 2 theta must always be greater than gl over u squared in this situation. Now for this, what we actually have to apply is the fact that our particle hits the wall at height h, that is vertically above our horizontal ground. Due to that, the value of h must be positive. So what we're going to do here is to apply this here and say, since h greater than 0, we can imply that all of this stuff on the right side here must also be greater than 0. So we can say L tan theta minus g L squared divided by 2u squared secant squared of theta must be greater than 0. Now in this case, what I can do is to take this negative term to the other side and write that L tan theta must be greater than g L squared divided by 2u squared times secant squared of theta. Now this already looks a lot like what we're asked to solve. However, here we can see instead of gl squared we have gl here and we don't have the 2. Now in this case, in order to get rid of that L squared, I can actually divide both sides by L. If I can do that, I can see both of these cancel. And we can also see to get rid of the 2 here, I need to multiply both sides by 2. But then we can also see we have secant squared of theta here and tan theta here. Now due to that, I am going to multiply both sides by cosine square of theta as well. If I do that, then secant squared of theta and cosine squared of theta cancel, since secant squared is equal to 1 over cosine squared, and therefore we get on the right hand side just gl divided by u squared, and on the other side we have this L divided, we have tan theta, but then we took this to the other side, so we have times 2 times, and then we have secant squared of theta taken to the other side, which is therefore going to be cosine squared of theta. So we have this inequality right here. Now simplifying this down, we can see tan theta is equal to sine theta divided by cosine theta. So therefore, if we cancel it for one of the cosine thetas, we have sine theta times 2 times cosine theta. According to that, we have 2 sine theta cosine theta being greater than gl over u squared, and as we know from our identities on trigonometry, we know that 2 times sine theta cosine theta is equal to double the sine of, or rather sine of double the angle theta. Due to that, we can finally say 2 sine theta cos theta is sine 2 theta, and therefore we have sine 2 theta greater than gl divided by u squared. And with that, we are done with this question. So now finally, let's discuss the marks award for this question. So at the start of the question, when you apply s equals ut plus half ad squared by assuming a time t, and you apply it in horizontal and vertical directions, for applying the horizontal direction correctly and getting this equation right here, you get 5 marks. Similarly, for applying the vertical direction correctly and getting this equation right here, you get another 5 marks. Now after this, when you take the first equation, rearrange to get t, and then substitute in the second equation to get rid of t, you get another 5 marks for writing down this equation right here. 5 marks for that. Now after that, when you say that given this equation, if h is greater than 0, then all of this stuff on the left hand side here must also be greater than 0, or rather everything on the right hand side here must be greater than 0. You get another 5 marks for simply stating that. For simply stating h must be greater than 0 and therefore this stuff must be greater than 0, you get another 5 marks. And after that, when you continuously rearrange this inequality, simplify, and h you'll get 2 sine theta cos theta being greater than gl over u squared, and substitute the trigonometric identity to say that sine 2 theta must be greater than gl over u squared, and write that down as your final answer, you get a final 5 marks. And with that, we are done discussing this question. So I hope you enjoyed. If you have any feedback, post them in the comments down below. If you have any questions, post them in the comments down below. Thank you for watching, and goodbye.